Greetings, fellow cosmic voyagers. I'm Space Master, and tonight we embark on an extraordinary journey, a voyage not just through the vast expanse of space, but through the very fabric of understanding. The universe, in its silent majesty, holds secrets so profound, so utterly astonishing, they challenge the limits of our imagination. We often gaze at the night sky, a velvet canvas spangled with distant lights, and ponder our place within this grand cosmic ballet. But what if I told you that beyond the familiar constellations and the gentle glow of planets lie truths that will fundamentally reshape your perception of reality? Prepare yourselves, for we are about to peel back the curtain on phenomena that defy everyday intuition. These are not mere curiosities. They are revelations, glimpses into the mechanics of a universe far stranger and more wonderful than we typically conceive. We're going to explore corners of existence where the rules, as we know them, are bent, broken, and beautifully reimagined. This isn't just about learning facts. It's about experiencing that exhilarating shiver of awe that comes when the mind expands to accommodate a new, breathtaking perspective on the cosmos. So, fasten your seatbelts, both mental and metaphorical. We're counting down 10 of the most mind-blowing space facts, revelations that will echo in the chambers of your curiosity long after our journey concludes. Each one is a testament to the universe's boundless capacity to surprise and inspire. Are you ready to have your mind expanded, perhaps even a little bit blown? Let the cosmic countdown begin. We've all grown up with a certain image of space, haven't we? The silent, cold vacuum. A place where no one can hear you scream. It's a compelling, if somewhat desolate, picture. But what if I told you that this profound silence is, in itself, a misconception? What if the void between stars, the seemingly empty stretches of the cosmos, actually hums with a subtle, ethereal music? It's not sound in the way our ears perceive it on Earth, through vibrating air molecules. Because yes, space is largely a vacuum. But it is far from inert or truly silent. The universe, you see, is permeated by plasma, the fourth state of matter, an electrified gas of ions and electrons. These charged particles, roiling and dancing to the tune of magnetic fields and stellar winds, generate electromagnetic waves. NASA spacecraft, like the Voyager probes venturing into interstellar space, are equipped with instruments that can detect these plasma waves. And here's where it gets truly fascinating. Scientists can convert these detected wave frequencies into the range of human hearing. They can sonify the cosmos. Imagine, if you will, listening to the voice of Jupiter's magnetosphere, a chorus of whistles and chirps created by trapped particles, or the eerie hum of plasma waves interacting with the planet's atmosphere. These are not random noises. They are the signatures of complex physical processes unfolding on grand scales. It's as if the universe itself possesses a subtle soundtrack, a symphony of electromagnetic vibrations that tells the story of its dynamic nature, its invisible currents, and its cosmic weather systems. So, The next time you gaze up at the stars, remember this. While you might not hear it with your unaided ears, space is not a domain of absolute silence. It is, in fact, alive with vibrations, a testament to the ceaseless activity of the universe. It sings, it whispers, it crackles with energy. We just needed the right instruments and a touch of human ingenuity to learn how to listen to its ancient, cosmic song. The silence of space is a myth. The reality is a subtle, pervasive chorus. Now, let's journey from the subtle sounds of space to an object of almost unimaginable brute force and density, the neutron star. When a truly massive star, many times the mass of our sun, exhausts its nuclear fuel, it can no longer support itself against its own immense gravity. The core collapses catastrophically, triggering a supernova explosion that blasts its outer layers into space. What remains behind, if the core isn't massive enough to become a black hole, is this incredible entity, a neutron star. Picture this. An object perhaps only 20 kilometers, or about 12 miles in diameter, roughly the size of a city. Yet, crammed into this relatively tiny sphere is the mass of 1.5 to perhaps 3 times that of our entire sun. The gravitational forces at play are so extreme, so utterly crushing, that they overcome the forces that keep atoms apart. Electrons and protons are squeezed together to form neutrons, hence the name. The matter within a neutron star is packed to a density that defies earthly comparison. To put this into perspective, consider a single teaspoon of neutron star material. If you could somehow bring that teaspoon to Earth, it would weigh approximately 6 billion tons. That's equivalent to the weight of about 900 Great Pyramids of Giza, all condensed into a volume smaller than a sugar cube. Imagine the sheer gravitational pull of such an object. The escape velocity from a neutron star is a significant fraction of the speed of light. It is a truly alien environment. These cosmic relics are not just dense, they are often spinning incredibly rapidly, some hundreds of times per second, emitting beams of radiation that sweep across the cosmos like lighthouse beacons. We see these as pulsars. Neutron stars represent one of the ultimate states of matter, a point where our understanding of physics is pushed to its very limits. They are a stark reminder of the powerful, transformative forces that sculpt our universe, creating objects of such mind-bending properties. 117 Earth days. It's a complex interplay of orbital mechanics and rotational dynamics. It serves as a profound reminder that our earthly experience of time, of days and nights and seasons, is not a universal constant, but a local phenomenon, shaped by the unique history and characteristics of our own world. Venus dances to a different cosmic rhythm entirely. Chapter 4. The Universe's Greatest Ocean. A quasar's watery halo. When we think of water in space, our minds often drift to icy moons like Europa or Enceladus, or perhaps the search for liquid water on Mars. These are exciting prospects, hinting at the possibility of life beyond Earth. But what if I told you that the largest, most voluminous reservoir of water in the entire known universe isn't on a planet or a moon, but rather surrounding a colossal, ancient black hole, billions of light years away? Astronomers have discovered an enormous cloud of water vapor associated with a quasar designated APM 08279 Plu 5255. This quasar, a superlatively bright galactic nucleus powered by a supermassive black hole, is observed as it was when the universe was young, only about 1.6 billion years after the Big Bang. And surrounding this energetic behemoth is a staggering quantity of water, existing not as liquid or ice, but as a diffuse vapor. How much water are we talking about? The estimates are almost beyond comprehension. Approximately 140 trillion times the amount of water in all of Earth's oceans combined. Let that sink in. 140 trillion Earth oceans worth of H2O, swirling in a vast cloud, many light years across, in the early universe. This discovery was a revelation, indicating that water, a molecule crucial for life as we know it, was abundant even in the cosmos's youth. This colossal reservoir isn't just a curiosity. It tells us something fundamental about the chemical evolution of the universe. The conditions around this quasar, with intense radiation and gas flows, were apparently conducive to the formation of vast quantities of water molecules. It suggests that the ingredients for water are widespread, and that water itself has been a common constituent of the cosmos for a very, very long time. The universe, it seems, has always known how to make rain, or at least a whole lot of steam. Chapter 5. Our Moon's Slow Farewell. A Celestial Retreat. The Moon, our constant celestial companion, the silent guardian of our night sky, the driver of our tides. It has inspired poets, guided navigators, and been the only other world upon which human feet have stepped. Its presence feels eternal, a fixed point in our cosmic neighborhood. But even this seemingly steadfast relationship is, in reality, a dynamic and evolving one. Our moon is, ever so slowly, drifting away from us. This isn't cause for immediate alarm. It's a gradual process, unfolding over astronomical timescales. But the fact remains. Each year, the moon recedes from Earth by approximately 3.8 centimeters, or about 1.5 inches. That's roughly the speed at which your fingernails grow. This phenomenon is a direct consequence of the tidal interactions between Earth and the Moon. The Moon's gravity creates tidal bulges on Earth, and as Earth rotates, These bulges effectively try to pull the moon along. This gravitational tug-of-war has a fascinating twofold effect. Firstly, it transfers angular momentum from Earth's rotation to the moon's orbit, causing the moon to spiral outwards into a higher, slower orbit. Secondly, this same transfer of energy causes Earth's rotation to slow down, meaning our days are gradually getting longer, albeit by a minuscule amount, about 1.8 milliseconds per century. This cosmic dance has been playing out for billions of years. Think about the long-term implications. Millions of years in the future, the moon will appear noticeably smaller in our sky. Eventually, it will be too distant to cause total solar eclipses. All eclipses will become annular, with a ring of the sun visible around the moon's silhouette. This slow departure is a poignant reminder that nothing in the cosmos is truly static. Even the most familiar celestial relationships are subject to the grand, unhurried laws of physics, forever reshaping the celestial landscape. Chapter 6: A Treasure Beyond Worlds. The Diamond Planet 55 Cancri A. Humans have long been captivated by diamonds, symbols of wealth, beauty, and endurance. We mine them from deep within the earth, formed under immense pressure and heat. But what if I told you there's a planet out there, orbiting a distant star, that might be substantially composed of diamond? Welcome to 55 Cancri, an exoplanet that truly redefines the notion of cosmic treasure. Located about 40 light-years away in the constellation Cancer, 55 Cancri E is a super-Earth, roughly twice Earth's diameter and about 8 times its mass. It orbits incredibly close to its parent star, completing a full revolution in less than 18 hours. This proximity results in scorching surface temperatures, estimated to be over 2,000 degrees Celsius, or 3,600 degrees Fahrenheit. But it's the planet's potential composition that has astronomers and dreamers alike utterly fascinated. Based on observations of its mass, radius, and the chemical composition of its host star, which is unusually rich in carbon, scientists have theorized that 55 Cancri E could be a carbon planet. Under the intense pressures and temperatures within such a world, much of this carbon could crystallize into vast quantities of diamond. Imagine a world where a significant fraction of its mantle, perhaps even its entire surface, beneath a thin atmosphere, is a glittering expanse of diamond and graphite. The estimated value, if one could even conceive of mining it, is a staggering $26.9 nonillion. That's 26.9, followed by 30 zeros. Of course, this is still a model, a scientific inference based on the available data. But the very possibility ignites the imagination. It suggests that the universe can form planets in ways far more exotic than we see in our own solar system. Planets, not just of rock and gas, but of materials we consider precious and rare. 55. Cancri E stands as a testament to the bewildering diversity of worlds that populate our galaxy, a shimmering jewel in the cosmic night. Chapter 7: Saturn's Fleeting Beauty. The Disappearing Rings. Saturn, the jewel of our solar system. Its magnificent rings, a breathtaking spectacle of icy particles and dust, have captivated observers since Galileo first glimpsed them through his rudimentary telescope. They seem so grand, so permanent, an enduring symbol of celestial elegance. But here's a truth that might surprise you, perhaps even sadden you a little. Saturn's iconic rings are not forever. They are, in cosmic terms, a fleeting phenomenon, and they are actively disappearing. Data from NASA's Cassini spacecraft, which orbited Saturn for over a decade, provided compelling evidence for this gradual demise. The rings are primarily composed of water ice, particles ranging in size from microscopic dust grains to chunks as large as mountains. These particles are caught in a delicate balance between Saturn's gravity, pulling them inward, and their orbital velocity, flinging them outward. However, they are also being bombarded by micrometeoroids and solar radiation. This bombardment, along with Saturn's own magnetic field, is causing a phenomenon known as ring rain. Charged water particles from the rings are being pulled along magnetic field lines and are essentially raining down onto Saturn's upper atmosphere. Cassini's instruments directly measured this influx, confirming that the rings are losing mass at a significant rate. Current estimates suggest that the rings could vanish completely in as little as 100 million years, or perhaps persist for up to 300 million years. While 100 million years sounds like an eternity to us, on the scale of the solar system's 4.5 billion year history, it's a rather short lifespan for such a prominent feature. It implies that we are living in a privileged era, a time when Saturn is adorned with its most spectacular regalia. It's a poignant reminder that even the most majestic structures in the cosmos are subject to change and decay, urging us to appreciate the transient wonders the universe presents to us. Chapter 8: Exotic Weather. Where it rains. Molten glass. Sideways. We Earthlings are accustomed to weather involving water in its various forms: rain, snow, hail. But venture out into the galaxy, and you'll find exoplanets where the concept of weather takes on truly bizarre and terrifying dimensions. Consider the exoplanet HD 1899733b, a hot Jupiter located about 63 light-years away. From a distance, it's a beautiful, deep azure blue, reminiscent of our own tranquil Earth. But don't let its serene color fool you. This world is a veritable nightmare. HD 18973b orbits incredibly close to its star, resulting in blistering atmospheric temperatures reaching over 1,000 degrees Celsius, or about 1,800 degrees Fahrenheit. Its beautiful blue hue isn't from water, but likely from silicate particles, essentially tiny grains of glass, scattering blue light in its atmosphere. And this is where the weather report gets truly extreme. The planet is racked by ferocious winds, estimated to blow at speeds exceeding 8,700 kilometers per hour, or about 5,400 miles per hour. That's more than 7 times the speed of sound. Now combine those scorching temperatures with an atmosphere rich in silicate particles, and add those hypersonic winds. what do? You get rain, not of water, but of molten glass. And because of the incredible wind speeds, this rain of liquid glass doesn't fall downwards. It flies sideways, whipping around the planet in a perpetual global storm of superheated, razor-sharp shrapnel. It is a world where umbrellas would be utterly, laughably useless, and survival impossible for any known life form. The study of exoplanets like HD 189733b pushes the boundaries of our understanding of planetary atmospheres and climatology. It reveals the sheer diversity of environments that can exist in the universe, from the relatively benign to the unimaginably hostile. It's a stark reminder that Earth-like conditions are perhaps not the norm, and that the cosmos is filled with worlds that defy our everyday experience in the most extreme ways imaginable. Chapter 9. The Cosmic Time Benders. How Black Holes Warp Space-Time. Black holes. The very name conjures images of ultimate destruction, of inescapable gravitational maws devouring everything in their path, even light itself. They are indeed regions of space-time, where gravity is so strong that nothing can escape. But black holes do more than just consume matter. They fundamentally warp the very fabric of reality around them, including one of its most fundamental dimensions, time. This mind-bending concept stems directly from Albert Einstein's theory of general relativity. Einstein taught us that gravity isn't just a force pulling objects together. It's a curvature or warping of space-time caused by mass and energy. The more massive an object, the more it curves space-time around it. And black holes, being unimaginably dense, create the most extreme curvatures possible. Imagine space-time as a stretched rubber sheet. A bowling ball representing a star creates a dip, but a black hole creates a seemingly bottomless pit. Now here's the crucial part. This warping of space-time affects the passage of time itself. According to relativity, time runs slower in stronger gravitational fields. So, for an observer situated near a black hole, where gravity is incredibly intense, time would pass more slowly relative to an observer far away in a weaker gravitational field. If you could hover safely near the event horizon of a black hole, a big if, your clock would tick at a significantly slower rate than a clock on Earth. Imagine an astronaut orbiting a black hole. To them, time might feel normal. But if they were to return to a spaceship further away, or to Earth, they would find that much more time had passed for everyone else. Years, decades, even centuries could have elapsed in the outside universe, while only a short period passed for them. Black holes, therefore, are not just cosmic vacuum cleaners. They are natural time machines, or more accurately, time distorters, offering a profound, albeit perilous, glimpse into the pliable nature of time itself. Chapter 10. An Uncountable. Infinity. More stars than grains of sand. We often try to grasp the immense scale of the universe with analogies. One of the most evocative and humbling is the comparison of stars in the sky to grains of sand on all the beaches of the world. Take a moment to truly contemplate that. Imagine every beach, every desert, every dune on planet Earth Collect every single grain of sand. It's a number so vast it strains the imagination, easily trillions upon trillions. Yet, the universe holds a secret even more staggering. Current estimates, based on deep field observations from telescopes like Hubble and Webb, suggest that the number of stars in the observable universe vastly exceeds the number of grains of sand on Earth. We're talking about hundreds of billions of galaxies, each containing, on average, hundreds of billions of stars. When you do the math, the numbers become astronomical in the truest sense of the word. Figures like 1 septillion stars, which is a 1 followed by 24 zeros. Let that number resonate for a moment. 1 septillion. For every single grain of sand on our entire planet, there are likely thousands, perhaps tens of thousands, of stars scattered throughout the cosmos. Each one a sun, many potentially with their own families of planets, their own unique stories unfolding across unimaginable distances and timescales. It's a scale that dwarfs human comprehension, a testament to the sheer profligacy of cosmic creation. This isn't just a numbers game. It's a profound reorientation of our place in the cosmos. It underscores our smallness, yes, but also the incredible richness and potential of the universe we inhabit. With so many stars, the probability of other worlds, other forms of existence, perhaps even other intelligences, becomes a compelling statistical argument. We are but one tiny part of an unimaginably vast stellar ocean, an ocean whose shores we are only just beginning to explore. The sheer number of stars is a silent, glittering invitation to wonder. And so, our journey through 10 of the universe's most astonishing truths comes to a close. From the subtle songs of plasma waves in the silent void, to planets made of diamond and worlds where it rains molten glass sideways, we've glimpsed the sheer audacity of cosmic phenomena. We've considered the unfathomable density of neutron stars, the temporal quirks of Venus, the slow departure of our moon, and the mind-warping nature of black holes. We've marveled at vanishing rings, colossal water reservoirs, and a number of stars that defies earthly comparison. Each of these facts is more than just a piece of trivia. It's a portal to a deeper appreciation of the universe's complexity, its beauty, and its often bizarre nature. The cosmos is under no obligation to conform to our expectations, and it is in these deviations from the familiar that the most profound learning and the greatest sense of wonder are often found. The universe is a book filled with endless pages, and we've only just begun to turn them. The quest for knowledge is an eternal one, and the universe is the grandest subject imaginable. I hope these revelations have sparked your curiosity, ignited your imagination, and left you with a renewed sense of awe for the vast, intricate, and ever-surprising cosmos we are privileged to inhabit. There is so much more to discover, so many more mysteries to unravel. Thank you for joining me, Emmett Rabani, on this exploration. Keep looking up, keep questioning, and never lose your sense of wonder.